Hello everyone, welcome back to the channel. This is Mohit Gowda, wearing the USN 1VE21 CS 101, pursuing my education in Sri Venkateswara College of Engineering. So, today we are going to learn about algorithm. So, the contents we are going to learn today. What is an algorithm? Properties of an algorithm, fundamentals of algorithmic problem solving, time efficiency and space efficiency, worst case, best case, and average case efficiency, performance analysis, asymptomatic notation and examples, and the conclusion. So, what is an algorithm? An algorithm is a set of steps of operations to solve a problem performing calculations, data processing, and automated reasoning tasks. An algorithm is an efficient method that can be expressed within finite amount of time and space. There are several strategies for any algorithm's design and evaluation, including brute force algorithm, divide and conquer algorithm, dynamic programming, and greedy algorithms. Each method has its very own strengths and weakness, and the choice of approach depends on the nature of the problem being solved. So, properties of an algorithm well defined. Each step of the algorithm should be clear and unambiguous. Effective. The algorithm should solve the problem it was designed to solve. Termination. The algorithm should eventually finish after a finite number of steps. So now, what are the fundamentals of algorithmic problem solving? First, analyze the problem. We should first analyze the problem. Understand the problem statement thoroughly and identify the requirements, constraints, and assumptions. Second, we should develop a solution. Design the algorithm using basic problem solving technique such as iteration, selection, and recursion. Third, code the solution. We should code the solution to translate the algorithm into a computer program in a specific programming language. So, what are the characteristics of an algorithm? First, it has well-defined inputs. Second, clear and unambiguous. Third, it is language independent. Fourth, it is feasible and it has finiteness and it gives well-defined outputs. So now we are going to see about the time efficiency and space efficiency in algorithms. First, time efficiency. It refers to the amount of time an algorithm takes to complete its execution. Space efficiency. It refers to the amount of memory an algorithm uses to complete the execution in the algorithm. So, the efficiency is divided into three parts: the worst case, the best case, and the average case. The worst case efficiency. The maximum amount of time an algorithm takes to execute for any possible input of size n. Then it is a worst case efficiency. When it's the best case efficiency. The minimum amount of the time an algorithm takes to execute for any possible input of size n, then it is a best case efficiency. Average case efficiency. The expected amount of time an algorithm would take to execute for a random input of size n is average case efficiency. So, when the algorithm takes the maximum amount of time, it is worst case. When it takes the minimum amount of time, it's the best case. And when the output comes in the expected amount of time, then it is the average case efficiency. So, what are the design techniques for algorithms? First, brute force. It is an iterative and exhaustive method used to solve problems through computing force. Second, divide and conquer. It divides the larger problems into smaller, more manageable subproblems to ease overall problem solving. Dynamic programming. It is used to break down bigger problems into smaller ones, and then find the optimal solutions over and over again to the same subproblems. So, brute force, it is through the computing forces. Divide and conquer, it divides the bigger problems into smaller problems and it's manageable. Dynamic programming, it also breaks down the bigger problem into smaller problems and then finds the optimal solution to the same subproblems. Performance analysis of algorithms. Empirical analysis. It measures the running time of an algorithm by executing it on real machines with different inputs. That means it runs an algorithm by executing it on real machines but with different inputs. Theoretical analysis. It provides a mathematical representation of the algorithm's performance, independent of machine and input. So, the asymptomatic notations and example. The first one, big O notation. It describes the upper bound of the running time as n grows. Omega notation. It describes the lower bound of the running time as n grows. Theta notation. It describes the average running time as n grows. So let's see the best case, average case, and worst case for linear search, binary search, bubble sort, and merge sort. First, the linear search. The best case of linear search is O O1. The average case is ON. The worst case is ON. Binary search. The best case is O1. Average case is O log n, and the worst case is also O log n. Bubble sort. The best case of bubble sort is O n, and the average case is O n2, and the worst case is O n2 of bubble sort. Now the merge sort. The best case of merge sort is O n log n. The average case is O n log n. The worst case is O n log n. So in merge sort, all the cases are the same for the best, average, and worst case. In bubble sort, the average case and the worst case are the same, while the best case is different. In binary search, the best case is different, while average and the worst case is the same. In linear search, it's also the same. The best case is different, and the average case and the worst case is the same. So now the conclusion and what we learned and where algorithms are used. Algorithms are the foundation of computer science that powers some of today's most innovative and innovation and successful technologies. Understanding the properties, design, and analysis of algorithms are essential skills that every computer science student should possess. So, what all we learned from this topic? Design and analysis of algorithm are crucial in computer science and software development. So, algorithms are required for software development and for computer science. The properties of algorithm and their importance we are learned in this. The next time you design an algorithm, keep the properties and complexities in the mind. So, finally, the applications where we can use the algorithms. Finance, used to manage financial portfolios and predict stock prices. E-commerce, used to develop strategies like product pricing, product recommendation, and fraud detection. Transportation, used for scheduling delivery, optimizing routes, and predicting traffic flow in public transport. Healthcare, used to analyze large data sets and diagnose illness. So that's it from this video. So in this video, we got to learn about algorithms, its properties, and the notations and the applications used from algorithms. So that's it from this video. Uh, Please do like, subscribe, and share the video. Thank you.